Welcome to today's lesson. I'm Siamasaka Kiandens, and so I'm going to take you through a lesson in chemistry. So we go straight to the lesson for today. Well, today again, we are looking at more concepts, and basically we are looking at the number of particles actually as expressed in actually a mole. And we note that actually 1 mole of molecules of a substance actually is equal to the relative molecular mass of any substance as expressed in actually grams. Okay, in other words, we are saying 1 mole is equal to relative molecular mass of a substance, and this substance should be actually expressed in grams, or in other words, 1 mole is equal to actually the number of particles, which is 6.022 multiplied by 10 to the power 23 molecules. Okay, and so we note that here we have a compound which is carbon. So this is a molecule. What it means is that 28 is actually the relative molecular mass of actually carbon monoxide. And so we are saying 28 grams would be equal to 6.022 multiplied by 10 to the power 23 molecules of actually carbon monoxide. Okay, so we have to express the relative molecular mass in 2 grams, and that will be equivalent to the number of actually particles. And the other thing we should know is that moles can be calculated by dividing mass divided by the molar mass of a substance. So M is actually molar mass of that substance, which is actually expressed in grams per mole. Okay. And so here is a question where they want us to calculate the number of moles in 300 grams of glucose. We know that the formula for glucose is actually carbon 6, hydrogen 12, and oxygen 6. So the first thing you need to do is to calculate the relative molecular mass of glucose. Which should be equal to 6, the subscript for carbon, multiplied by the relative atomic mass for carbon, plus 12, the subscript for hydrogen, multiplied by the relative atomic mass for hydrogen. plus subscript for oxygen is 6 multiplied by the relative atomic mass for oxygen. And this gives us actually 6 multiplied by the relative atomic mass for carbon is 12 plus 12 multiplied by relative atomic mass for hydrogen is 12 plus 6 multiplied by actually relative atomic mass for oxygen, which is 16. And this one gives us actually 72 plus 12 plus 96. And this gives us actually 180 as the relative molecular mass for actually glucose. And therefore, the molar mass for glucose would be actually 180 grams per mole. Once we have found actually the molar mass, we can now use our formula where we said if you are calculating the number of moles for glucose, to be equal to actually mass of glucose divided by the molar mass of actually glucose. Which gives us actually the mass. We are told it is 300 grams divided by the molar mass. We got 180 grams per mole. And therefore, what we get is actually 1.67 moles. So these are the number of moles for actually glucose. Second part of the question is also wants us now to calculate the mass in 3 moles of carbon dioxide molecule. And so the first thing we need to calculate is relative molecular mass of carbon dioxide, which would be 1, the substitute for carbon, multiplied by relative atomic mass for carbon, plus subscript for oxygen is 2 multiplied by relative atomic mass for oxygen, which gives us 1 multiplied by relative atomic mass for carbon, which is 12, plus 2 multiplied by 16. And this will give us 12 plus 32. And this one gives us actually 44. So the relative molecular mass for carbon dioxide is actually 42, but the molar mass for carbon dioxide therefore would be 44 grams per mole. We know that molar mass is expressed in grams per mole. And now that we have known the molar mass and we know the number of moles, we can say actually moles for carbon dioxide would be equal to mass of carbon dioxide divided by the molar mass of carbon dioxide. And here we are told actually there are 3 moles, which is equal to the mass is the one we want to actually to calculate. Divided by the molar mass, we found that it's actually 44 grams per mole. And therefore we can cross multiply and we find that actually the mass for carbon dioxide would be equal to 3 moles multiplied by 44 grams per mole. And we know that this mole here will cancel with that one. And therefore what we are going to remain with is actually 132 grams. And so these are the grams for actually the carbon dioxide molecule. Okay, so we have the last part of the question, which is asking us actually as follows. Given that in 2.0 times 10 to the power 3 molecules of carbon, hydrocarbon, which is carbon Y, and the hydrogen 4 compound has a mass of 9.5 grams. Calculate the value of Y as well as the relative molecular mass of the compound. And so we are aware that if you have the compound, the relative molecular mass of this compound should be equal to actually the Avogadro number of molecules. Of the hydrocarbon. And therefore, this should be actually the molar mass, and therefore this expressed in grams should be equal to 6.022 multiplied by 10 to the power 23 molecules. And therefore, we can find that actually this is 12 y. You are getting the relative molecular mass plus actually 1 multiplied by 4 grams, which gives us 6.022 multiplied by 10 to the power 23 molecules. And therefore, we are going to have 12 y plus actually 4, or this is in grams, giving us 6.022 times 10 to the power 23 molecules. And so here they told us that we are given that actually 12 y plus 4, which is actually the relative molecular mass, should be equal to 6.022 times 10 to the power 23 molecules. Now we are told that actually the mass is actually 95.5 grams, which gives us actually 2.0 times 10 to the power 23 molecules of this compound. And you can merely cross multiply here to find the value of y. And so we're going to have 12y plus 4 multiplied by 2.0 multiplied by 10 to the power 23 should be equal to 9.5 multiplied by 6.022 multiplied by 10 to the power 23. This is after cross multiplying. And therefore, we can say 12y plus 4 should be equal to 9.5 multiplied by 6.022 multiplied by 10 to the power 23 molecules divided by 2 times 10 to the power 23. And you note that actually here, this one and this one are going to cancel. And when you divide 2 there, it will definitely give you 28.6045, which is equal to 12y plus 4. Therefore, 12y would be equal to 28.60 We can write this one properly somewhere. So this is 28. And so we can say 12y plus 4 is equal to 28 point actually 6045, and therefore 12y is equal to 28.6045 minus 4, which gives us actually 24.6045. And here we have 12y. Therefore, our y would be equal to 24.6045 divided by 12. And then our y would be equal to actually 2. So we have found the value for y, and meaning that our compound is actually this compound which was actually CyH4 is actually this compound. Okay, because we have found actually the value of that one. Now the other question is saying calculate relative molecular mass of this compound. We know how to calculate relative molecular mass of this compound now, which we know, which is carbon 2, hydrogen 4, would be equal to 2, the substitute of carbon, multiplied by relative atomic mass for carbon plus a subscript for hydrogen, which is 4, multiplied by the relative atomic mass for hydrogen, which will give us 2 multiplied by 12 plus 4 multiplied by 1, which gives us 24 plus actually 4, which gives us actually 28. Okay, as the relative molecular mass for this compound actually. Okay, so I thought today we can look at how we can use actually the more concept to solve a few problems. And so I hope you are going to actually subscribe to my YouTube. And those who want to actually further questions, one-on-one actual tuitions, you can actually contact me on WhatsApp. My WhatsApp number is actually +260 977 4199, and my email address is siamasaka@gmail.com. All these are small case. Okay, so these are small case. This is a K here, but all these are actually small case. So you can actually, if you want lessons which are one-on-one, 49 actually here. 2 plus 260 977 419949. Then we can communicate and we can arrange the times when we can meet and actually have intensive lessons tailored for actual passing examinations. So I thank you.